Okay guys, so number 3 says for the relation y is equal to x squared, complete the table of values. Again, same x numbers. Take this 0, put it in there, but square it. So 0 squared, and if you don't know on your calculator, don't guess. 0 squared is 0. 1 squared, 1. 2 squared, 4. 3 squared, 9. 4 squared, 16. Okay, while we're on this table, let's do the first differences right away. Okay, which is letter E. So we're going to do the first differences right away. So, second one minus the first one. 1 subtract 0, 1. 4 subtract previous one, 3. 9 subtract the previous one, 5. 16 subtract the previous one, 7. Okay, so let's graph it again. In this case, we can't plot just the first and last because it's not a straight line. Okay, it's not a straight line because this is not going up by the same amount. So in this case, we do have to graph all the coordinates. So zeros, first coordinate, up top 1 and 1, 1 and up 1, right 2, up 4, right 3, up 9, right 4, up 16, which is at the very top. Okay, now this one, if you picture it, is a nice smooth curve with an arrow. It continues. This graph, or this rising arrow, represents the equation y is equal to x squared. So I'll tell you, not that you really have to know, but this is called an exponential function. Exponential function or relation, same thing. Why? Because it increases exponentially. Okay, so it's going faster and faster. So an example of that in real life would be an airplane taking off. Okay, it's going faster and faster. Okay, based on the relation, based on the graph, the relation is, now it's nonlinear. So it's either linear in grade 9 or it's nonlinear. Don't worry about saying that it's exponential. It's either linear or nonlinear, okay? Describe the pattern in the x values, still increasing by ones. Okay, calculate the first differences. We already did that. What do you notice about the values of the first differences? So let's go back to the first differences. 1, 3, 5, 7. There's a pattern, right? Okay, it keeps on increasing. The increases by 2, increases by 2, increases by 2. Okay, so there's a pattern. They're not equal, but there's a pattern. Okay, so what do you notice about the value of the first differences? There is a pattern. I'm not going to lie to you. Most of the time, the first differences are equal. It's the same number, which means it's linear. So if the first differences are equal, like the previous two questions, it's a linear line, okay? We don't spend a lot of time on exponential functions. It's more grade 10 stuff, okay? So I love this question because from a table of values, we're going to fish out an equation and then we're going to make a prediction. So remember I told you a couple pages ago that it's important to come up with an equation, which is like a formula, because then we can make predictions. Okay, this is what I mean by that. So it says, use first differences to determine which relations are linear and which are nonlinear. And then we want you to write an equation, which is like a formula representing each relation. And then extrapolate the relation to predict the outcome of the seventh house. Okay, we're going to do that at the very end. So look what this says over here. It says in A, how many segments do you need to build one house? So let's just count. 1, 2, 3, 4, 5, 6. Okay, so you need 6 segments to build one house. Okay, let's call this small h, okay, for house, and let's call this S. Make sure it's an S and not a 5 for segments. And we're going to use these variables after in our formula. So how many for 2 houses? Let's do this. 1, 2, 3, 4. Okay, 5 right in the middle. 6, 7, 8, 9 segments. Okay, did I miss one? I think I missed one. 1, oh yeah, I did. I missed these 2. 10, 11. Okay, so we need 11 segments for the next one. Okay, now what we want you to do is, we don't want you to start counting again. We want you to see if you can follow some sort of pattern in your answers over here. Okay, and if you look at it, 6 to 11 increases by 5. Let's just count this one. Okay, there's not a lot, but we'll see how it works out. 1, 2, 3, 4, 5, 6, 7. Now let's do these ones. 8, 9, 10. And then let's do the roofs over here. 11, 12, 13, 14, 15, 16. Okay, 16. Now again, there's no way you're going to make 4 houses. You know, like, can you imagine making 7 houses? You're going to be there forever starting to count the line segments, and it's going to get confusing and the whole bit. Okay, so what we want you to do is we want you to come up with an answer with 4 using these numbers. So let's do the first differences with just these 3. 11 subtract 6, 5. 16 subtract 11, 5. So in order for the next answer to be 5, what's this one got to be? So something subtract 16 equals 5. 21. Okay, so now you know that for 4 houses you need 21 line segments. Now before you predict for 7, let's come up with a formula. Okay, so first of all, it's linear because it asks in the question if it's linear or nonlinear. So here's your answer. Since the, I call them FD, not fire department, first differences. Since the first differences are equal, which they are, they're all 5, okay? Since the first differences are equal, it is linear. And that's it. That simple sentence. Okay? Now let's come up with a formula. Okay? Capital S, which represents number of segments that you need, is equal to, slope is first. The first difference is, you'll learn, is your slope. Okay? So it's 5H. And now let's test it out and see what happens. So if I have, look at my pencil, if I have one house and I substitute in there, 5 times 1 is 5, but the answer is actually 6. So if we go plus 1, now let's test it out. So let's put 1 in for H. 5 times 1 is 5, plus 1, 6. Let's test the second one out. Put 2 in for H. 5 times 2 is 10, plus 1, 11. So it works out. Let's put 3 in there. 5 times 3, 15, plus 1, 16. So now we don't have to do this anymore. Now we got this magic formula, which we can put any number in for h. They want us to put 7. So therefore, for the 7th house, here's what you do. Rewrite your formula. S is equal to 5, make sure it's a 5, h plus 1. And now I'm going to put 7 in for h. Right underneath it. 36. 36 what? 36 segments. Okay? So you need 36 segments for 7 houses. Okay? So I'm going to stop the screen and then we're going to do letter B, which is same thing, same type of question, only for tiles. Okay?